part B. On top of that, you may want to download the notes for this chapter also. So it's a new set of notes. Huh? You ready? Yeah, it's called gene expression. Yeah, you know what a gene is, right? Remember? Okay, very specifically today, maybe today, you should have covered this thing called transcription and translation. Oh, you did this before? Okay, but you remember correctly, yeah? You recall a long time ago when you did a chapter on proteins, then you were asked to like convert DNA into proteins. You did that before? No. Right? Yeah, it was RNA, remember? mRNA. Okay, so actually, last year, Miss Lim already went ahead. Okay, in preparation for this very day. Everyone ready? Okay, first and foremost, you will find that in this particular SLS, can you see at the top right hand corner, do you see this like family tree button? Do you have that also? Or not there yet? Yeah. Okay, can you click on the family tree button? Then if you scroll down, you should see that there is a folder A, B, and C. Can you see that? Okay, so we realized that the SLS tends to be two split up. Like one chapter have many SLS all split across the board. Very hard for you to find. So now we've organized it in terms of chapters. If you go into this particular chapter, you will find three different sections. So we'll use the same SLS, but we'll find the different sections, so it's easier for you. Okay, so today we will access A and B. We'll begin first with A. If you click on A, then you'll find the first chapter, first few pages for today's lesson. Okay, once you're there, I'd like you to enter. Okay, we'll just start off with a quick, fun sharing. Today, the new topic we're going to go into is called gene expression. And in gene expression, it's all about the interactions. But I don't want to tell you what the word interactions mean. I'd like to listen from you first. What do you think interaction means? What does interaction mean to you? For today, we're going to start off with an interesting sharing session. I'd like you to sketch or find a picture online that represents interaction to you. Alright, and then after that, we'll do a quick sharing before we dive into this chapter. Okay, what does interaction mean to you? The word interaction. Chemistry. Okay, so I'll give you around 7 minutes, okay, maybe 5 minutes. Yeah, wait, anyone follow Marvel? Yes. Oh, yesterday, you know what came out, right? Yesterday Doctor Strange trailer came out. So I'm going to remember already. Yeah, who likes Benedict Cumberbatch? So yesterday the trailer came out. Like 1 day, 21 million views. Ready? Alright, 5 minutes for you to share about what interaction means to you. Yes. me funny things. It's too early in the morning for me to handle weird stuff. Okay, Ethan, can you check? Hey, I believe you can view each other's submissions. Okay, if you click view submissions, you can see each other's submissions. Wow, your chem teacher will be so proud.
Why everyone doing chem?
Maybe your file corrected. Let's see your file. Okay, I'd like everyone to go to your and have a look at everyone's work. Rita, what kind of interaction you have? Then what does this mean? You know what this looks like to me? It looks like anal face. Is this anal face? Oh yeah, but no, anal face should have the microtubule in the middle, right? Okay, let's listen to some of your what you put up today. Some of you have like Bluetooth connection to each other. Found exactly the same images. Shijie, Yuan, same image. Yeah? Okay, maybe you'll get Shijie to share. Shijie, why do you choose this image to represent interactions? Okay, this is your top search result. Okay, but to you, like, you must have chosen it because it resonated with you in some way. How does this represent interaction to you? Okay, there are like two or more people communicating, so there's an interaction. There seems to be involves several parties, and then there seems to be communication involved. Okay, so there seems to be many parties. Right? Many parties. Okay, this is a top head, party head up. Okay. Many parties, and you say that there's communication. Okay, thanks, Cynthia. Okay, next, let's look at, okay, I see that Raymond has put effort to draw. Okay, Raymond, may I invite you to share with the class why you drew this image? Okay, socializing. So that's what interaction is to you. It involves some sort of socializing. What's spelled? Yeah. Okay, thank you. Let's look at others. Aziz. Okay, Aziz. Why do you choose this image to represent interactions? Okay, let's listen to Aziz. Aziz, you speak out a bit more. Okay, let's listen to Aziz. Oh, okay. So, do you call them notes?
Yeah.
What are notes?
It's a graph theory.
Oh, it's a math thing.
Yeah,
You all know this, is it?
no.
Oh, is this an advanced math thing? Python. Okay. Okay, so there seems to be connections. And in fact, some of the connections are overlapping. Okay, let's have a look at others. You see, what is this? You see why you choose this image?
It's hydrogen bond.
Okay, so?
The molecules interact with each other.
Okay, so it's interacting with each other through a particular kind of bond. Okay, so it's some sort of interaction. Interaction perhaps through bonds. Okay, let's look at others. Okay, who over here? Xiao Yang also chose hydrogen bonding as an interaction. Okay, this one I need to understand what's happening. Nikita, Yuta, why Sorry? Oh, it's a harmful interaction. That's interesting. Yeah, but why is she so happy? You sure it's harmful, huh? Do you like resonate with this? If I were to strangle you, if I strangle you, you also smile with it. Okay, harmful. Sorry, harmful to who? To the woman. Yeah, but that's interesting. The idea that you brought up that some interactions could be harmful. Perhaps could some interactions be beneficial? I don't know, man. Two of them look like they are quite happy. What about this one over here? Ryan, why do you choose this domino set? So that to use the interaction. Okay. Alright, so when one falls, the other will fall. How will you put it? How will you summarize this in your sentence? One fall, the other will fall. How will you describe this in another way? They fall simultaneously. Okay. So it seems simultaneous. Okay, let me think. Kind of one leads to another. Yeah, kind of. One thing kind of leads to another. It's an interesting concept. Here we scroll down. Critic, what's this? John use this textbook? Oh wow. Primary school. Okay, on. I like about the means to just like let me know that it's not today you're using it. Okay, maybe Ilya, you share with us what this represents to you. It's like what? Or it works two ways. Is that what you're saying? Okay. So it kind of goes two ways. Okay. Alright, thank you for the sharing this morning. Why are we talking about interactions this morning? Because what we're going to do in this chapter is grounded in interactions. We want to know how the various parts work together to achieve what we want to achieve, namely transcription and translation. As we go through this chapter, I want all of us to see if we can find the various aspects of interaction that we're talking about. The idea that perhaps when we look at interactions, that there are many parties involved. And that perhaps one thing leads to another. Can we find any connections with each other? And what kind of connection is it? Is it a connection involving bonds? Or does this connection involve communicating to each other? Or is it like, I don't know if chemicals or enzymes can socialize? How will this connection look like? Will it be two ways? Will it be simultaneous? Will one thing lead to another? Or will it be harmful or beneficial? This is what we're going to look at today. As we run through this chapter, I'd like you to keep interactions at the back of your mind. Because we want to see how everything comes together and work with each other. Right? Today's new chapter is called Gene Expression. And by now, we've already covered what a gene and allele is. I'd like everyone very quickly, plus with your partner, how would you define a gene? Okay, in your own words. How would you define a gene? Now, what is a gene? In your own words, in your own words. Ready? Okay. Amanda, what is a gene? How you saw the answer by accident?
Oh no, I was
Okay, I never experienced this before. She accidentally saw the answer. Okay, Ninja, what is a gene to you? okay, it is like a set of instructions or like a recipe book to help define what your traits or what's the second word you use? Or traits that can be inherited. Okay, thank you. Possible? That's what a gene is. Yeah, that's one way you could call a gene. What about Yishan? Yishan? Yes, Yishan?
Yeah, sure.
Sorry?
Yeah,
Oh, sorry. Yes, Yishan. What is a gene to you?
A part that contains the hereditary
Hereditary what? Trait. A what that contains?
part.
A part, okay? It is a part. In fact, it is a segment of the entire DNA. Yeah, that can be inherited. Okay, thank you. Maybe one last one. Emily, what is a gene to you? Okay, a sequence of DNA that can make something. If I were to amalgamate everything that has just been said by India, Emily, and Yeshen, alright, I hear that when we talk about what a gene is, it involves a segment of DNA, right? Yeah, like what Yeshen is saying, she's saying like a part or something. This segment of DNA is responsible, it codes for something, and it results in a trait, and that can be inherited. That's something that most of you all brought up this morning. What exactly does it code for? It codes for protein specifically. This protein could be a multitude of things. It could be enzymes, it could be structural in nature, it could be hormones, etc., etc. Lots of things are proteins. Some students wonder, why don't our DNA code for things like carbohydrates or lipids? Well, because we don't really need to. As long as we have a protein like an enzyme that can build these carbohydrates or these lipids, then there's no need to synthesize the lipids from scratch. So proteins are a very powerful thing. It is so versatile, depending on how we piece them together. That's what a gene is. And today we add one more word to the back, expression. The idea, I hope at the end of today, we're going to find out how we express the gene. So if you see the word expression, it means to say transcription plus translation. That's what gene expression means. Okay? So if someone were to just simply write, I want to express this gene, they mean to say it involves these two processes to get a protein. Okay? I must say, as I was marking through your TE, I find that your use of vocab is quite solid. Okay? It's not bad. For those of you that don't quite know how to use it yet, I can tell that you refer and learn how to practice using it. Okay? Amanda, if not, you feel like that. I spelled your name wrong. How do I spell it wrong? Oh, I wrote Amanda, and then I wrote for you Amanda. Okay? No, I call you Amanda. So okay, I'm so sorry. It's very common. So I type in Amanda. Then Amanda, did I type you Amanda? Yeah. Okay, so your use of vocab I find for this class pretty strong. Alright, you keep it up. We're going to practice using along the way. Okay. Next up, let's go to part B. Okay, so how will we go to part B? Also figuring out. Okay, can you go to part B of this chapter? Okay, top right hand corner, you see the family tree. Then go to part B. Okay, we're going to dive into gene expression right now. Okay, we spend some time reading the learning outcomes first. What we're going to do. And then we'll, what's your time? Okay, click to part 1. Yeah, what? Just pause. Oops, just pause it. Okay, sorry, play. It should be okay. Like that. Okay, that's okay. Okay, yeah? Now, can you go to part 1? What's what word? Okay, how are you know to use a family tree thing?
Oh, there's an X dash section. Oh, so that's what it was.
Okay, part 1, we will skip it first. Okay, that will be your homework for today. Let's go to part 2.
Wait, why is it restricted?
Is it restricted? Why you? Yeah. Is it restricted for anyone? Oh.
Huh?
Oh, okay. So you must submit the first part, is it? Okay. Can you click submit? And then you should be able to go to part 2.
Why must be this first part then we can go to second one?
Okay?
Not how you follow.
Alright, this morning we spent a bit of time recapping what a gene is. Next level, we're going to recap what an allele is. Okay? So, for part 2, this is what I'd like you to do. We have already, we sort of understand what the difference between gene and allele. For those that forgot, this is what you can do this morning. You can watch this video right at your table. But for those that are ready, I'd like you to try this particular question 1. Okay, question 1 wants you to wants you to pretend that this particular gene is 18 nucleotides long. Okay, pretend that this particular gene is 18 nucleotides long. You know what nucleotide is? Yes, remember? Okay, well, we'll find out soon. Okay, then they ask you to write down the sequence for the tall allele and the sequence for the dwarf allele. What does this mean? What does it mean to write out 18 nucleotides, tall allele, and dwarf allele? Okay, you can use, I'd like you to make up what the code for the gene. If I say again, I'd like you to make it up. That means you can come up with any sequence you want. Alright? But you must be able to represent to us and to your partner how the genes are different from each other on an allele level. Okay, I'd like everyone to try now this particular question to the best of your interpretation, what the question is asking for. And then we'll do a quick sharing. Okay, you can make up your sequence, but you must represent 2 alleles. How will you represent a single nucleotide? You can use the alphabets A, T, G, or C to represent the nucleotides. Okay? Alright, so I would like you to represent 2 alleles using 18 nucleotides each. How would you represent this? If you can represent it, then we will see whether you understand the difference between alleles and genes. Yes. Good. So it's just this segment of the DNA. But there are 2 versions. Yes. Oh, but you cannot submit again, is it? Then unfortunately, it's going to they are quite different, is it? Okay. Okay, if you're ready, you can submit. Okay, good. I see various interpretations of this question. 18 nucleotides. How will you represent two alleles? Up to you. Okay, you can make up your sequence.
Oh no, I messed up.
Oh, so you go plus first. Look, this side. How you represent? Okay, so I noticed that the sequence. Oh, this is a double stranded. But so far looks okay, around 2 more minutes before you share with your partner. Yes. Sorry. They are both the same gene. They are the same gene, but different versions. Oh, okay. Okay, from what I'm seeing here, this entire thing is single. It's not a single gene. The gene is a small thing. So you write A, G, and T. It's not actually and then also what you're doing here is that you're making two different square meters. Yeah, correct. It's within there. Yeah, correct. Correct, yeah. And you're doing it as this one. So imagine you squeeze in this section to get this. What you're saying is A, C, then what makes alleles different? Yeah, so what makes them different? Okay, how different? Okay, 30 more seconds. We're going to share some of your responses. Yeah.
Yeah, whatever. Wait, I
Okay, so we have a lot of responses coming in. Okay, still waiting for some of you to submit. Okay, time is up. Now let's have a look at some of your responses. Okay, the task for you was this. they ask you to draw two alleles that are 18 nucleotide pairs long. You see the word pairs? Okay. So I notice some of you are 18 nucleotides, then you try to create double strand, it's very short. 9 on each strand. Okay, so 18 nucleotide pairs long. So what does this mean for you? Okay, let's have a look at some responses. Tom, hey, Ye Xuan, is there a short? Okay, there's a short one. Okay, let's have a few details. Okay, Ye Xuan, could I get you to share what you've done? Just describe what you've done. Can we all pay attention?
Also both is the same, just that like one pair is different.
Okay, both what is the same?
The
How will you describe it? Let's use the vocab.
DNA sequence.
Yeah, okay. Both DNA sequences are the same except
For one pair.
except for one.
One pair.
Except for one pair. Okay, can you spot the pair that Ye Xuan changed up? Second last. Oh, you're very sharp, huh? Okay, from GC to TA. Yeah? Okay, so this is how she represented alleles. Actually, spot on now. Okay, this is how we will represent alleles and genes. Genes are sequences of DNA. Different versions of different genes. What is the key difference? Just perhaps a small little swap in the base pairs. For example, a swap GC with TA. Truly, alleles are quite similar to each other. Okay, the sequences cannot be too different. If it's too different, you'll produce a totally different protein, right? But the fact that the change is so minute, the protein is the same but slightly different. Maybe black eye color, blue eye color, but still carry out the same function. Okay, so 18 nucleotide pairs long. Can we check? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 pairs. I'd like to introduce one vocab for you. Sometimes we may use the word base pairs. So they may say 18 base pairs long. Okay? I could say this DNA sequence is 18 base pairs long. I could even say that I want to swap out a base pair. Because it's very weird to just swap out one nucleotide. They come in a pair. Okay? So you can only swap out base pairs, you don't swap out individuals. Okay, so that was Ye Xuan. Okay, let's look at some other responses. Okay, this one is interesting. Okay, this is interesting. Tall allele, dwarf allele. And then we see different alphabets being used. Capital T, A, B, and here. T, A, B, and here. I would say, okay, so we bear in mind, we use these kind of alphabets to represent single alleles. So for example, big T represents one allele already. Small t will represent one allele also. Okay? What does the allele represent? It represents a DNA sequence. So if I combine two of our answers together, it will mean something like that. Big T could be something like that. Yeah, very easy. Okay, so next one. A, G, 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 T. T, T, C, 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 A. Okay? When you see these alphabets, these are alleles. What do they truly represent? They represent a sequence of DNA. It's just it's very painful for you to write down an entire sequence, right? So you just write down the alphabet will do. Okay? So what does this mean? Actually, this means that there are several alleles here, right? There are in fact 1, 2, 3, 4, 5, 6 genes and 12 alleles here. You see? 6 genes, 12 alleles. Okay? As I scroll down, I see a lot of you with largely the same idea. Okay, maybe this one looks interesting. Let's have a look at this. Oh, it's Android. tall allele, dwarf allele. Offhand, looks not bad. I see that the main change is at the third base pair, GC to AT. Everything else is largely the same. Yeah? So same gene, but slightly different alleles. However, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9 base pairs. Okay, it's not 18 base pairs. So we take note of the terminology base pairs. Okay, any questions? So far, yes. Yeah. Okay, so good question. Oh, so I is asking, can we? Okay, so let me ask, can we change more than one base pair? That's fine. So at the end of the day, there's a threshold. I don't know what the threshold is per se. It depends on protein to protein. But if we change too much of the sequence, it becomes a totally different protein. We could change one base pair or two base pair, maybe a third base pair over here. If it's largely the same, it serves the same function, just maybe a slightly different function, it's still okay. Alright? I personally actually don't know the threshold for each protein. Okay? Alright, so that was section 2. Just a quick idea to try and make sense of what a gene and allele is on a genetic level. If you're okay, you can submit, then you can go to part 3. Okay, part 3 today is the core. Okay, we are going to leave today understanding what transcription and translation is. Unfortunately, because our projector audio is not working, I'll need everyone to watch it personally right now. If you have your headphones, you may take it out. How about it might work? Okay, I just try. Okay, play. Alright, so this is what we'll do for the next part. I would like everyone to watch. Listen. I'd like everyone to watch this video on what transcription and translation is. But I'd like you to bear these questions in mind first. Can you scroll down to the interactive thinking tool? You see transcription, and there's one tab for translation. The key question is, what interactions do you observe? Keep this question in mind. Okay? Alright, once you got the question in mind, then you watch the video so that you can type in as many responses as possible. Okay, we want to capture what you watched. Okay, for the next 3 minutes, the time is yours to watch the video. The time starts now. Okay, so I will play the video. When the video is out, I know you have done watching also. You can switch on subtitles. You can switch on the subtitles. Once done, you write down what interactions you observe.
particular section. Okay. So you take your time to complete this section, and then we'll go through this tomorrow. You take your time, and then we'll discuss this tomorrow. So today we have I think that's a problem. Even though I thought of translation, I can do translation. Because I submitted I don't think that's a feature. I think that's about. Why? Okay. You say it's a bug means it's a bad thing, right? You just say it's a feature. It means it is just as it is.
complete this particular part. Yeah, say again, complete up the entire of section 3. The remaining time. You cannot complete within lesson, and then there will be something you can go to do. Okay, I think just